All right, number 2. We have a ball rolling down a ramp, but we have some different parameters right here. Again, let's write down our values for, our equations for position and velocity and acceleration versus time. Our position as a function of time is going to be equal to our initial position plus initial velocity times time squared. Our velocity as a function of time is simply equal to initial velocity plus acceleration times time. And once again, our acceleration as a function of time is simply going to be constant. Okay, well, what is our acceleration? Well, this is one that we had a little bit of trouble with in class, if some of you recall. As the ramp is oriented right here, the ball is going to be rolling in this direction. You can say that then the acceleration is going to be in that direction. But look, it's moving from a positive location, 50, back to 0. This is our, you could say that's our x final right here is 0. So it's moving from 50 to 0, which means we're going to have a negative acceleration. We're actually also going to have a negative velocity too, because we're moving back to the origin. So velocity is going to be negative as well. So our acceleration, it's some negative value. We don't know what it is, but we'll just simply label it as such. And you know what? I need to move this up a little bit. Sorry, folks. I'm going to move this just like that there. Okay. Our acceleration is a negative value, so it's simply going to be constant negative. So let's pick a negative value right here and make sure it's constant, just like that. Negative acceleration. If we go back up to the top, whoops, I need to stop doing that. Let's okay, sorry. Take a look at our velocity. Again, we do have a negative velocity as well, because we're starting from velocity 0, and it's going to have some velocity down here. But again, since we're moving backwards in position, it means we're going to have a backwards velocity. We're going to have a negative velocity. We're moving negatively position-wise, we're going to have a negative velocity. So, what is our equation for our velocity versus time? Well, again, it's VI plus AT. Do we have an initial velocity? Nope, that's 0. But we do have an acceleration. So our velocity at any point in time is going to be acceleration times time. Now, again, a way I've been writing this, so we're reminded that it's negative acceleration, is negative absolute value. Let me draw that a little bit better there. Darn it. There we go. Negative absolute value of acceleration times t. This reminds us that we have a negative velocity. So if we simply wrote velocity of function of time equals at, that would be correct. But since acceleration is negative, we want to put the negative out front to remind us of that. So this is probably a little bit better, which means, again, we have a linear relationship between velocity and time. But since it's negative, we have a negative a. That means it's going to be going down to the right. So we have, what's our initial velocity here? 0. Okay. So we're going to be starting at 0. We're going to have a negative linear relationship between velocity and time. That's supposed to be a straight line right there, but hopefully you get the picture. Okay, and let's see position versus time right here. Well, what's our initial position? Our initial position is 50. Okay, so we're going to put that in for our initial position here equals 50. Oops. Plus, what's the initial velocity? Well, it's 0. Okay, so plus 0 times time, which is really just 0, plus 1/2 at squared. But oh, wait a minute, we forgot that the acceleration is negative, isn't it? Oh, goodness. I'm just going to back up there. we have a negative acceleration, so I'm going to put minus 1/2 times the absolute value of a times t squared. Again, that means the exact same thing, but we're reminded that the acceleration is negative, and therefore it's going to make our position move backwards towards the origin, not forwards. So what's our initial position right here? Our initial position is 50. So we need to start that on our position versus time graph. So that's 50 centimeters, I believe is what it was. Okay, what's our initial velocity? Our initial velocity is 0, which means we've got an initial slope of 0. But since the acceleration right here is negative, it's going to make this velocity and therefore the position more and more negative. So it's going to start out at 0 velocity and get more and more negative. And we're going to stop our graph at 0 right here because it rolls from 50 down to 0. So that's where our graph stops. So hopefully that helps. That is question number 2. Let's do question number 3, and hopefully you'll be even more prepared for the test tomorrow. All right, let's clear that and bring this one up here. Good heavens, that's not centered very well. Okay. And you know what? I'm going to resize this. Just sit tight with me there, folks. I didn't do a very good job of that. Can we get the whole thing on there? Yes, we can. Okay. Great. Okay, we've got a ball rolling now up the ramp. We've got a ball rolling up the ramp. So it's going this way, but, and I should probably erase that there, which way is the acceleration moving? The acceleration is moving, that is, it's working in the opposite direction. The acceleration is working that way. So if our ball is rolling positively from 0 to 25 to 50, but the acceleration is operating the opposite way or the negative way, then our acceleration is going to be negative. It's serving to slow our ball down and bring it more to a stop, which we can see up here is what actually happens. Our final velocity is 0. So it comes to a stop. So this ball is rolling along a table, you might say, and then hits a ramp and goes up and then comes to a stop. That's what's happening right here. One thing also I need to point out is that this initial velocity is going to be greater than 0. It's going to be greater than 0 because otherwise it would have no chance of getting up the ramp. So our initial velocity is greater than 0. Right here it says that it's not equal to 0. It's true, but it also needs to be greater than 0. This is a little cut off here. It's supposed to say time is equal to 0, so this is our starting point. And also our initial position is equal to 0. So the ball is rolling from position 0 to 25 to 50, starting with a velocity, but it's got a negative acceleration that means it's got an acceleration working against it. So the question is, at any point in time, what is the acceleration or the velocity or the position as a function of time? Well, once again, our acceleration is going to be a constant negative. Negative right there. So we're going to pick a negative value and stick with that. That's going to be our acceleration over time. Over time, that acceleration doesn't change. It just happens to be negative. All right, velocity versus time. And, I didn't write my equations here. You know, I'm going to write my equations for x as a function of time equals initial. Sorry, you guys are probably tapping your foot waiting for me here. Plus vi times t plus 1/2 times acceleration times time squared. And our velocity is a function of time is equal to initial velocity plus acceleration times time. Okay, velocity is a function of time. Well, what's our initial velocity? Well, it's something positive. It's something positive, so it's going to be greater than 0, so we're going to leave that in there. So our velocity as a function of time is initial velocity. But we have a negative acceleration, recall. So I'm going to say, again, I'm going to put this negative out front. minus the absolute value of the acceleration times t. Okay, so that whether we plug in our acceleration as positive or negative, this just reminds us that it is negative. Okay. So, again, once again, we have a linear relationship here between vi and t, but it's a negative linear relationship because of the negative acceleration. What's the slope of that line? What's the negative slope of that line? It's the negative value of a right here. So, if that were to be -1, then that slope would be -1. Where do we start our graph, by the way? Okay, well, our initial velocity is greater than 0. So it needs to start up here. And what's our final velocity? Go back up here. Well, our final velocity is 0. So that means that even though we have a negative slope, it's going to be starting at a positive velocity value and sloping down to 0. Hopefully I can make it all the way to the end. Close enough. Okay? So it's starting with a positive velocity and getting right to the top of the ramp and just barely coming to a stop. That's what that means right there. So this is our velocity as a function of time. It's a negative. The velocity is getting more and more negative because the acceleration is causing it to be more negative. All right, the last one. Here we go. Position as a function of time. Well, what is our initial position? Let's go back up here again. Sorry for the sliding up and down the whole time. Our initial position is 0. Sorry, that got cut off there. So we're going to drop that out. But we have an initial velocity, so it's going to be vi times t. And we do have an acceleration, although it's negative, so minus 1/2 absolute value of a times t squared. Well, here we have a squared relationship, so it's going to be a curve. And it's going to be a negatively bending curve because our acceleration is negative. But where does it start? Where's our initial position? Okay, our initial position is 0. Is at the origin right here. But what's our initial slope? Our initial slope is the initial velocity right here, which is greater than 0. So we need to start with a positive slope. Like that. Okay, this is the starting position, but this is the starting slope because our initial velocity is positive. Put a little positive in right there. Okay? But the acceleration is going to make it become more and more negative to the point where the final slope, that is the final value of the velocity, is 0. So our final slope, pardon me, is 0. So we're starting positive and moving up the ramp. The acceleration is pulling it down, pulling it down, pulling it down. And I just missed that right there. Let's try that again. Goodness. Right here. There we go. There we have it. And our x as a function of time it's gaining displacement because after all we're going from 0 to 50, but we're losing velocity. We're starting with a positive velocity right here. That's our vi, and our final velocity equals 0. So there you have it. That's our ball rolling up and down the ramp problems that we did in class, but here they are in video form for you to check out and hopefully brush up before your test tomorrow. And again, don't worry about numbers 4 and 5 because we didn't do them. But this is numbers 1, 2, and 3. Hope they help, and hope you have good luck on your test tomorrow. See you then.